Hey there, welcome back to our YouTube channel. Today we are tackling an interesting problem, finding the correct index for a target value in a sorted array. Let's dive into it. You can find this problem over LeetCode with the name search insert position. It is described here as given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were present in, if it were inserted in order. You must write an algorithm with log n runtime complexity. Now, what does it mean? According to this, we are given a sorted array of distinct integers. We need to return the index of a target value if it exists. Otherwise, we return the index where it would fit to maintain the sorted order. Importantly, we must solve this in big O of log n runtime complexity. Here three examples are given. In first example, we have nums array with elements 1, 3, 5 and 6 and a target value 5 is given. Now we can see that 5 is present here at index 2 in this nums array. So we have to return the index value of that where the target value is present. So the output will be 2. In second example, we have nums array 1, 3, 5, 6, target is 2. We can see that the target 2 is not present in nums array. So firstly, we need to insert this target into this nums array. So if we insert this target in this nums array, it will come after the 1 and before 3. So the index of this new value will be 1 and we have to return that index only. Similarly, the third example is also given. Let's first solve this problem with a simple brute force solution, ignoring time complexity. The idea behind this approach is to iterate through the array from the start, checking each element one by one and comparing it with the target. As we go through the array, we want to find either the index where the target exists or the index where it would fit if it were inserted in order. Now let's understand this with an example. Suppose we have a nums array with element 1, 2, 4, 5 and 8 and a target value 5. So now for the each element of this nums array starting from first index, that is 0 index, till the last index, we have to check if the element is greater than or equals to the target value, and if this condition satisfied, then we have to return that index only. Now at index 0 the value is 1 and we will check if this value is greater than equals to the target value, that is 5. So here this condition is not satisfied, so we will ignore this condition and move to the next value, that is 2. Now at nums1 we have the value 2 and we will again check if it is greater than or equals to 5. The condition is not satisfied. Now again we will move to the next index, that is second index. Value here is 4. We will check if it is greater than or equals to 5. Condition again not satisfied. Now we will move to the next index, that is index 3. Value here is 5 and compare it with 5 if it is greater than or equals to 5. Here we can see that the condition is fully satisfied, that is 5 is greater than or equals to 5. So we have to return this index only, that is 3. So output for this is 3. Now in our second example, suppose we have a nums array of element 1, 2, 6 and 8 and a target value is again 5. Now we will start from the 0th index of the nums array. At 0 index we have value 1 and we will compare it with the target value, that is 5, and check if it is greater than or equals to 5. Here this condition is not satisfied. So we will move to the next value, that is 2. At index 1 in nums array the value is 2. Again we will check if it is greater than or equals to 5. Condition not satisfied. Now we will to the next index, that is 2 and value here is 6. We will check if it is greater than or equals to 5. We can see the condition here is satisfied. 6 is fully greater than or equals to 5. So the output for this is 2. So this is what we have to do in this brute force approach, and this process of finding the index of array is known as linear search. In this searching algorithm we have the time complexity of big O of n, and we can see that this is greater than big O of log of n, and we were asked to solve this problem in big O of log of n. So this condition, this This process of solving the problem is good, but in our case, it will not satisfy the condition of the lead code. So we have to optimize this time complexity. Now, before going to the optimal approach, suppose you are having a book of 1000 pages and you want to open the page number 501. So how you can do this? The first approach is that open the first page and see if that page is your desired page. If not, open the next page and continue the same process. S- Following this process, you can reach your desired page after some time. This is what we were doing in our linear search. Now think about how you would actually search for a page in real life. Instead for starting from page 1, you would like to open the book somewhere in the middle and check the page number. If the page you opened, suppose you opened page number 40 and it is too low to the desired page, that is 501. So you can ignore the left part of the book and you will proceed for the remaining part of the book. Similarly, imagine now again you opened the next page from the remaining part of the book and suppose that page is 801, which is too high than our desired page, that is 501. So we can simply remove the right part of the book including that 801 page number and we will proceed with this middle part of the book. Now again we will open another page from this book and if that page matches to our desired page, we will stop there and otherwise we will proceed with the same process. This process of finding the page in a book is much faster because we are cutting the book into halves each time instead of flipping through it sequentially. In the same way, we can apply this efficient search technique called binary search to our problem. It allows us to find the target index or insertion point in a sorted array in just big O of log n time complexity. So let's see how it works. Suppose we have a array nums with element 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 and the target value 8. Now we have to find this target value in this nums array. Now in our process of opening the page number in a book, what we were doing were selecting a page from somewhere in middle of the book and searching if that page is equals to or smaller than the desired page or greater than the desired page and taking the next step on the basis of that only. Now don't you think the selection of the page number which we open firstly will also affect the speed of our code? So get the more efficient solution. We will always select the middle element of the array and we will find it using the formula mid is equals to start plus end divided by 2 where start is the starting index that is 0 and ending index is 9. Now in our first step when we pass this array to binary search and try to find its mid element, now this time start is 0 and end is 9, when divided by 2 it will result to 4. The value at fourth index is 5. Compare this with target value. We can see it is smaller than the target value. So we will ignore this left part of this array and will proceed with the right part of this array. Now again implement the same process on this right part. This time the start index is 5 and the ending index is 9. When divided by 2 it will result to 7. Now the value at 7th index is 8. Compare it with the target value. We can see the target value is equal to the index value. So we can see that in the binary search we only got the answer in 2 steps and so we have to return this index only. Now we can use this binary search in our coding to get the time complexity of big O of log n. This is the code for this binary search. I hope you got these both the methods of finding the element from any given array